This lesson, I'm going to show you how to simplify some algebraic expressions, and in doing that we're mainly just going to be multiplying terms, dividing terms, and taking terms to a power. And before I go on, just the bits and pieces here of what I'm talking about, because I'm going to be using these three words here. We've got the coefficient, which is we can say the number in front of the letter, or the value in front of the variable. We've got the exponent and the base. The exponent is the little number that's raising something to a power. And what it's raising to a power is called the base. So in this case, the base is x. And the base of this expression is not 6. So I'm going to be using these terms, and hopefully we can understand how to do these. Okay, so first example here, I've got m squared times m cubed times m. Now, just what does that mean? That means m squared is m times m, and that's times m cubed, which is 3 more m's, and then finally times that last m. And that's a lot of m's, so we're going to want to come up with a shortcut, and we can count the number of m's, 1, 2, 3, 4, 5, 6. So repeated multiplication is shown by exponents. So m times itself 6 times is m to the 6. Okay, and you're wondering there must be a shorter way, and there will be a shorter way. Okay, now I have coefficients. The coefficients are 3 and 9. And so if I want to write this out in full, this is called full, and that's exponential form. This is full form without any exponents. I would write 3p squared is 3 times p times 9 times 1, 2, 3, 4, 5. Kind of messy. So that's a long way of writing it. In algebraic expressions, we always write the coefficient first. So the numbers come first. So 3 times 9 is 27. And p times itself, 1, 2, 3, 4, 5, 6, 7 times, is 27 times p to the 7th. And I don't write a times sign in my final answer, so I say 27 p to the 7th is my simplified algebraic expression. Simplified expressions have no times sign or divided by signs. Okay, by now you should be saying, I don't want to write this out in full because it's too long and cumbersome. Let's come up with a rule. All right, well, we look at the coefficients, 3 and 9, and we look at our coefficient of our final answer, and we can figure out something fairly quickly. We look at our exponent of our final answer, 7, and we look at our exponents of our original expressions here. Okay, and we can quickly come up with a rule. And the same with this one. 2, 3, no exponent, and 6. Well, if there's no exponent to begin with, there is. It's just we don't show it. It's just a 1. So 2 plus 3 plus 1 gives me 6. 2 plus 5 gives me 7, and 3 times 9 is 27. Okay, so we can come up with a general rule if you want to write it down. Okay, so here's our general rule, and I messed up right there. That is a plus m plus n. So if we have no coefficients, like this one right here, our answer is just we just add the exponents. Okay, like we did here. 2 plus 3 plus 1 is 6. And if we do have coefficients, like we did in here, we multiply the coefficients. So ab is a times b, and we still add the exponents. So, I mean, in short, when we're in these examples, if we don't want to write this one out in full, we multiply the coefficients and add the exponents. And if there aren't any exponents, like this b right here, we'll put a 1 there. So go ahead and try this one, not writing it out in full, but using the general rule here, and see if you can get it. Okay, well, did you get this? Negative 8 times 6 is negative 48. 7 plus 5 is 12, and 3 plus 1 is 4. Okay, so we've got a coefficient of negative 48, and our exponents are 12 and 4, which are the sum of the exponents with the same base. Okay, let's try one more of these. And I used to say multiply the big numbers, add the little numbers, but we'll say multiply the coefficients and add the exponents. So see if we can combine this. Simplify means, in this case, write it as one term. one expression. So go ahead and pause it and see if you can do that one. Okay, did you get 48 x to the 7th, y to the 8th, and z to the 3rd? If you did, good job. If not, just make sure if it doesn't have an exponent, put a little 1 there, put a little 1 there. And when we write a term, we've got all these x's and y's and z's and numbers. Coefficients comes first, and then write the variables in alphabetical order, x, y, z. And I think I got all that. Okay, let's move on. Okay, next one's what we're going to do is we have powers to a power, and let's do what we did here real quick. Write it out in full to see what it means. M6 to the power of 3, what does this mean? It means M6 times M6 times M6. That's what it means. And using my previous rule, which was if we're multiplying powers with the same base, I can add the exponents. 6 plus 6 plus 6 is 18. Okay, I got my answer. And you can probably see a pattern before I even give it to you. Okay, and that pattern is, well, if I'm taking a power and raising it to a power, I'm just going to multiply these exponents to get my final answer here. The general rule would be this. Okay, well, what if I have a coefficient here? What if I have a coefficient in the mix? 3x4 squared, well, that means 3x4 times 3x4, and I go back to my previous rule, which is multiplying the coefficients and adding the exponents. So 3 times 3 is 9, and 4 plus 4 is 8. So that's 9x to the 8. Okay, so I want to do this every time, but I don't want to write it out in full every time because that takes a long time and it's kind of annoying. Okay, so before we do the next one, let's see if we can come up with a general rule when we have a coefficient involved. So if we have, let's say, ax to the m raised to the power of n. Well, everything in here is getting squared. And these get multiplied. 4 times 2 is 8. We figured that out. Well, not 3 times 2 is 9, but 3 squared is 9. So what that means is that this coefficient is going to get raised to that power as well. So my general rule over here is going to be a, whatever that power is, a to the n, times x, and I'm still going to multiply these exponents here. Okay, so here we go. If we like formulas and if we like general rules, there they are. Okay, so let's do this one with a general rule without writing it out in full. Everything in here is getting raised to this power. 12 squared, like I'm doing here, 12 to the power of 2 is 12 times 12 is 144. And now I do my power to a power rule, which gets multiplied. 3 times 2 is 6, x to the 6, and 5 times 2 is 10. Y to the 10. Done. Very poorly drawn x there. Okay, that's nice. Let's try another one here. Okay, no coefficients here, so straightforward. Go ahead and try this one. This is just using this general rule right here. Nothing fancy, don't write it in full. Okay, is this what you got? 15 times 3 is 45, 7 times 3 is 21. Simplified expression, done. Keep going. Oh no, a fraction. Okay, don't panic. But if you do panic, write it out in full. What does this mean? This means x cubed over y to the 5th times itself 3 more times. Okay, so when we do write it out in full, we can kind of hopefully go back to our old rules and say, oh, okay, I'm multiplying powers with the same base here. What happens there? The exponents get added. 3 plus 3 plus 3 is 9. Same down here, 5 plus 5 plus 5 is 15. Okay? Okay, so if you want to, you can write a general rule for fractions too. It's just like a power to a power here gets multiplied. Same here. 3 times 3 is 9, and 5 times 3 is 15 as well. So if we want to write a general rule for a fraction, we can. Okay, we'd write it like this. Instead of writing it out in full, it's just the fraction is going to be the numerator is going to be raised to this power, and the denominator is going to be raised to that power. Okay, let's look at this example here, and we're going to use this general rule here. Everything in the numerator is going to be raised to the power of 5, and everything in the denominator is going to be raised to the power of 5. So don't write it out in full. Just raise the top part to the power of 5, and the bottom part to the power of 5. So rewrite it so it looks like this. Okay, so the purpose of doing this is not to have too many rules, but to take it back a step to a general rule that we already know. So this general rule right here is this one, raising a power to a power when I have a coefficient involved. Now let's do this rule right here. This is not 2 times 5, but 2 to the power of 5, which gives me 2 times 2 times 2 times 2 times 2, which is 32, I think. And then 3 times 5 is 15. And this is 3 to the power of 5, 3 times 3 times 3 times 3 times 3. And I'm using my hands to count that on, and I know that's 9 times 9, which is 81, times another 3. 81 times 3 is 243, I think. I'm pretty sure. And then I do my multiplying powers. 2 times 5 is 10. Okay, that wasn't too bad. Take a look at it. Okay, so if you're still with me, hanging in there, we've got one more thing to do, and that's just division. Problems like this. So take a look at this one, x to the 5th divided by x cubed. Okay, and I'll write this one out in full to get the idea. X to the power of 5 means x times x times x times x times x, and x cubed means, well, you get the idea. Okay, so that's it in full. We're not going to do that every time. This is just to get the idea. Now comes the concept of cross-canceling. Now what we do is x over x. Now, I can cross-cancel those because basically x over x is going to equal 1. So when I divide a fraction by 1, or when I divide anything by 1, I'm not changing its value, and that's why I can do this if they're connected by a times sign. I cannot do it if they're connected by a plus sign. So I can take that, I can cross-cancel those, and I can cross-cancel those. Because really I'm taking this fraction, I'm dividing by 1, dividing by 1, dividing by 1, as long as x doesn't equal 0. So dividing by 1 doesn't change anything, and what am I left with? X times x, which is just x squared. And when I cross-cancel everything out on the bottom, it doesn't turn to 0, it doesn't turn to anything, it actually is 1. Okay, and I get x squared over 1. Now, I don't need to write that over 1, because if I have like 10 over 1, 10 divided by 1 is just 10. So x squared divided by 1 is just x squared. Okay, now for the next example, I'll write it out in full just to get the idea, but all the ones are going to cross-cancel are on the top instead of the bottom this time. Okay, so I wrote it out in full, and it's kind of a pain. I wrote it 7 times and 3 times up here. Cross-cancel, cross-cancel, cross-cancel. And again, remember, when you cross-cancel everything on the top or everything on the bottom, you're left with a 1, not a 0. So that's a 1 on the top, and that's a 1, 2, 3, 4 on the bottom. A times itself 4 times is a to the 4th. So that's 1 over a to the 4th instead of a to the 4th. It's similar to if I have a fraction like 4 over 16. 4 over 16 simplifies to a quarter. Okay, so I cross-cancel the 4, goes into 4 once, and 4 goes into 16 4 times. So we can't forget about that one there. It's fairly important. Okay, what about coefficients? Now notice I haven't come up with a general rule yet, because I know you can go, okay, I can subtract the exponents. 5 minus 3 is 2. Well, you got to be careful with that, because if we don't want negative exponents, which we don't at this level, we can have negative exponents, they're fine, but at this level we're going to keep them all positive. You've got to look at where there are, like for example this, where there are more a's. There's more a's on the bottom, so our exponent's going to be on the bottom. Here, there's more x's on the top, so our exponents are going to stay on the top. In this case, we don't write it over 1. Okay? Now with coefficients, it's kind of a different deal. We're not going to subtract 16 and 20. We're not going to subtract the coefficients, because those are numbers. We can simplify that like a fraction, 16 over 24. So work these two kind of separately like this. Okay, so we have a number part and we have a algebra part. And the number part we simplify by what's the highest common factor that goes into 16 and 24? It's going to be 8. 8 goes into 16 twice, and 8 goes into 24 3 times. Now here, we're going to do our thing. Now where are most of the x's? They're on the bottom. How many more x's are on the bottom? 5. If I were to cross-cancel here, I'd cross-cancel 2 on the top. So I'd get 1 over x to the 5. And I didn't write it in full this time. Okay, I just kind of did this part in my head. So now we multiply across. 2 times 1 is 2. And 3 times x to the 5th is 3x to the 5th. Okay? Or I could write that 2/3 as a coefficient. But you don't have to. Either one of these answers is fine. I almost fell for a major mistake here. We can't write 2/3 as a coefficient because that x to the 5th is on the bottom. So ignore my statement a couple seconds ago. Sorry about that. Leave it like this. Okay, last one. Let's see here. Separate the number part. 15 over 5 times. Write the algebra part out. A cubed b8, a b10. Simplify the number part. 15 over 5, 15 divided by 5 gives us 3. Okay? If there's no exponent there, make it a 1. Okay, 3 minus 1 is 2. Where are most of the a's? They're on top. So that's a squared. And I'm going to put it on top. Now, b8, b to the 8th and b to the 10th, where are most of the b's? They're on bottom. So the b's are going to stay on the bottom. And 10 take away 2 is going to give me, 10 take away 8 is going to give me 2. That's b squared. Now here, most people go, oh, I don't know where that 3 goes. Well, remember, this actually is 3 over 1. Okay? Because 15 over 5 is the same as 3 over 1. And I multiply, if you want to write it like this to help you remember that, that's fine. So now I multiply across. 3 times a squared is 3a squared. And 1 times b squared is just b squared. Now I'm done. So hopefully that helped. Kind of a long video, but we covered quite a lot. Okay? So, until next time, thanks for watching.